So here we have the first part of Module 3. We can hear from this, the motor's gonna spin one way for 2 seconds, turn around and spin the other way. And we have the motor driver with everything connected to the Arduino. And then we just have the code over here. So it's just writing to those 2 pins. This is without the button or the potentiometer, the first part. So this is the updated setup for the lab, plus the button being used as a digital interrupt. So we have the button on a digital pin, which is, for in this case, pin 3. And we have added a Boolean of motor direction, so that's basically gonna determine in the interrupt which direction the motor is spinning. And then in setup, we have added the button pin as an input pin and attached an interrupt that calls the change direction function when that button is pressed. So in here, we can scroll down and we've removed this stuff from the void loop. And in change direction, we have this here. So if motor direction is high, it spins one way, and then otherwise it's gonna spin the other way. So if we upload this code, have to plug it into the computer first, sorry about that. But if we upload that, and we go over here, we have this. And if I press this button, it will begin to spin one way, and then it will spin the other way. And then it'll spin the other way, and then it'll spin the other way. So this is the final part of Module 3. Part A, so we have attached the PWMA pin to pin 9, and in this case the that pin is also an output. So what that's doing here is it's reading the pot value from the A0 pin, and then depending on what that value is, it's gonna write a value to the PWMA output as a voltage, and that's gonna dictate the speed. So we can see here, it's spinning very slowly. You can hear it a little bit, but when we turn the pot, it's gonna start going really fast. And if we turn it again, it's gonna slow down, fast, slow down. So that's what that's gonna do there. So this is my linkage for Module 3, Part B. So you can see when this one's going 5, this one is going 10, about that, and then right after 60, it's a little bit off just because of the way I set it up, but it gets stuck. And then if you go around the other side, it will go back to 0. It's a little off, but here it will go around the same side, and then right at 60, it's gonna get stuck again, and then reset. So based on that, I have my code here, which is just the code that we were given, except I made the delays longer so I could really see the change from part to part. And then I recorded my data from both directions, and from that I gathered that the linkage, the first part connected to the motor is able to go 60 degrees without getting stuck, and the output is able to therefore go 120 degrees without getting stuck. And the reason it gets stuck is just because of the length of those the cables. It physically can't get past that point because it would need to the links aren't long enough to mesh past that point. I remember there's an equation we learned in RB 2001 that says depending on the lengths of the links, it will either be able to go for a full circle or it won't be. So this is one that wouldn't be able to go, wouldn't satisfy that equation, and therefore it isn't able to go full circle, which we see from this data.